operations in the military. It is absolutely vital that you know your equipment inside and out.
Joking aside, according to NATO, a soldier needs 5 liters of water per day, and that's 8 or 9 if the weather is hot. So when thousands of troops need to be supplied, water becomes a critical issue. But it's not just overseas in military operations that having access to water is essential. The readiness of the military overall is dependent on the reliability of the support structure, such as water and energy systems. U.S. military installations in the United States and overseas both rely on water to carry out their missions and must be able to provide for those living, working, and training on those installations. Some military installations, because of their geographic isolation, can operate like small cities and contain all critical public works infrastructure such as water and wastewater systems within their own fence line. I'll provide an example of a base I worked at in California, Camp Roberts, which has a handful of groundwater wells, water tanks, distribution system, and a wastewater treatment plant as shown in the photos. This is fairly common for older installations as well. Still, other installations may be close enough to or previously established within a city and are therefore connected to municipal supplies. Some installations may operate under a mix of both internal and external sources. When thinking about the reliability of a water system, factors such as age, capacity, and redundancy of the infrastructure come into question. Since water is so critical, it's important that water operations and systems are resilient. Military resilience can be defined as the capacity to overcome the negative effects of setbacks and associated stress on military performance and combat effectiveness. For the purpose of this presentation, resilience means the ability to accomplish mission when external and internal energy and water services are disrupted. Natural and man-made disasters such as hurricanes, floods, droughts, and now also cyber attacks are all threats that could disrupt the drinking water system. Take, for example, Hurricane Michael, which completely devastated Tyndall Air Force Base in 2018. We cannot predict when natural disasters that lead to pipe breaks or water disruptions will occur, but we can plan for how to respond to these events and build contingencies. So this is where installation energy and water plans, also known as IWIPs, come into play. IWIPs build resilience into energy and water systems, into the infrastructure, and into the systems themselves for mission continuance in the face of the worst-case scenarios. In 2016, the Assistant Secretary of Defense for Energy, Installations, and Environment directed all U.S. Department of Defense installations to prepare an installation energy plan. The purpose of the plan was to coordinate higher-level energy initiatives, planned energy projects, and the installation's master plans. Since 2016, additional related policy and guidance, such as multiple executive orders and the Defense Authorization Act of 2018, passed. After realizing the equal importance of water, some branches of the military began developing IWIPs. The 2018 Final Army IWIP Guidance Memo is a consolidation of multiple policies that inform the installation energy and water planning process. It's important to mention that water has historically been less of a concern than energy until recently in the military's energy and sustainability programs. Water rates in the U.S. are generally low and often make water savings projects financially unattractive for the DoD. However, recent studies have found that the watersheds and the water systems on U.S. military bases are increasingly vulnerable to issues of water supply and demand. While always seemingly available, water can often become a higher priority than energy, and some energy assurance projects are driven by the need to maintain continuous operation of the water system. Because this is a water security class, I'm going to be primarily speaking about water over the next slides, but just know that energy and water resilience are linked and included in the IWIPs. To prepare the IWIP, installation staff and facility managers work collaboratively with all mission owners, tenant organizations, and relevant stakeholders to develop a plan that considers current mission, future plans, associated energy and water needs, and the strategies to effectively meet those needs. One of the main goals of the IWIP is to sustain necessary energy and water services for a minimum of 14 days for all critical missions. Other goals of the IWIP include reducing energy and water use and lower total operating costs while still fully maintaining services. So IWIPs have a 5-step process. This is probably a lot to digest, so the key steps of the planning process are establishing the baseline conditions and requirements, and then using those to create what's known as the future case, which is how does the installation meet the requirements and what are some of the potential projects or solutions. This is usually done through a series of in-person workshops and virtual meetings. Without mentioning the particular installations, here's some planned projects that may be implemented in the future as a result of the IWIP process. IWIPs consider stakeholder input to determine how the installation is going to prioritize projects. The installation has to be part of the plan since they have to execute it, and and the plan must be financially and environmentally achievable through the IWIP guidance. Some of the known issues over the past few years in developing IWIPs are related to a lack of consistency resulting in a failure to meet policy and guidance requirements. The creation of an IWIP template is now used across all installations, both overseas and in the United States, to prepare the plans. Additionally, some of the main questions and concerns that occur during the workshop include: what is the return on investment and how will this project get funded? Funding constraints sometimes result in constrained thinking. I believe IWIP should have a list of practical projects that are implementable in the short to mid-range, but also long-range dream projects that might have otherwise not been suggested, but could very well be a practical solution in the future. As military installations continue to become more and more encroached by sprawling development, it might be essential for more installations to form partnerships and establish mutual aid agreements. A lot of military planning goes on behind the scenes, and rightfully so, but I believe there's an opportunity for more cooperation, collaboration, and learning that strengthens water and energy resilience beyond the military installation's boundaries. As we learned in class, watersheds and groundwater aquifers stretch across state lines and fence lines. With partnerships between local municipalities, larger infrastructure projects, and implementation of new technology and concepts like water reuse might become more palpable. Take the desalination plant on Fort Bliss, an Army base in Texas, for example. This facility is the largest inland desalination plant in the world. Although it operates at only about 15% of its capacity, the plant has the ability to meet all of Fort Bliss's water needs, as well as those of much of the city of El Paso.
So we have a water problem, freezing water, become a gas problem, become a power problem, become a bigger gas problem, become a bigger power problem, become a water problem and a humanitarian crisis.
Last, as you may recall, one of the goals of the IWIP was to be able to still support critical missions if there was a 14-day disruption of either energy or water supplies on the installation. I believe that the Department of Defense IWIP process and experience in developing energy and water resiliency for its military installations can be applied to cities, counties, or even states that are currently without a resilience plan to better prepare them for future disasters.